Hello everyone, and a very warm welcome back to Part 3 of your Edgevo's Software Engineering course. I'm absolutely thrilled to be guiding you through today's explainer. We've covered a ton of ground in Parts 1 and 2, looking at the fundamentals of how we gather requirements, model our systems, and handle the absolute basics of coding and testing. But today we are stepping into the realm of advanced software engineering. We are officially moving past the days of writing every single line of a program from scratch. Today, we're talking about software reuse, so let's dive right in and look at how modern professionals actually build large-scale systems.
Here is a quick look at our roadmap for today's session. 1. Introduction to software reuse. 2. The 4 levels of reuse. 3. Concept reuse. 4. Benefits versus problems. 5. The reuse landscape. And finally, 6. Course summary and exam focus.
Okay, Section 1, Introduction to Software Reuse.
To set our foundation, I want you to picture a skyscraper under construction. When builders put up a massive high-rise today, they don't show up to the site and start mixing their own cement from scratch, right? Or forging their own steel beams on the pavement. That would be completely inefficient. Instead, they order prefabricated, highly tested components and assemble them. Well, software engineering has evolved in the exact same way. Until about the year 2000, developers mostly wrote bespoke code. But today, modern enterprise software engineering is absolutely dominated by software reuse. We assemble complex systems using existing, tested, and reliable components. This huge shift is a direct response to businesses demanding lower costs, faster delivery, and much higher quality.
Moving on to Section 2, the 4 levels of reuse.
Okay, grab your notebooks and maybe a highlighter, because understanding these 4 levels is absolutely critical for your upcoming exams. Software reuse isn't just one monolithic thing. It actually happens at radically different scales. We can visualize this as a sort of hierarchy, building from the absolute smallest unit of code right up to massive, off-the-shelf software packages. At the base, we have object or function reuse. Then moving up, we get to component reuse, then application reuse, and finally, system reuse at the very top. Let's unpack every single one of these, starting right from the top down.
First up, we have system reuse. So what is it? System reuse is simply buying or reusing a complete off-the-shelf software system. At this top level, you aren't writing new core functionality at all. You're taking entire complete programs, which are often made up of multiple application programs themselves, and incorporating them. Think of a massive university adopting an entire suite of management systems for student records, finance, and HR, and integrating them into one giant system of systems.
Stepping down one level, we hit application reuse. This is defined as adapting a generic software product line for a specific customer. In this scenario, you have a core software architecture that already exists, but it just needs to be tweaked to suit the distinct behavior required by an individual client. You might incorporate an application without changing it much, or you might heavily configure a generic version so it perfectly aligns with the specific business rules of the customer you're working with.
Next down is component reuse. This involves plugging in a third-party subsystem or framework. Basically, a component is a collection of objects that operate together to provide a related function. Let's use a very beginner-friendly analogy here. Imagine you're building an e-commerce website. You are definitely not going to write a system to securely process credit cards from scratch. That is incredibly difficult and, quite frankly, way too risky. Instead, you just plug in a pre-built payment gateway component like Stripe or PayPal. You adapt it slightly, add a bit of your own code to connect it to your shopping cart, and you're good to go. Finally, at the very base level, we have object or function reuse. This is defined as using standard, built-in programming libraries. And honestly, this is the exact type of reuse you're already very familiar with from your early coding classes. When you need to calculate a square root in Java or C++, you don't write the complex mathematical algorithm yourself, do you? No, you simply import a standard math library. You reuse classes and functions that are freely available, linking them right into your newly developed code. So, just to recap our 4 levels from top to bottom, we have entire systems, customized applications, plug-and-play components, and basic objects and functions.
Right, Section 3, Concept Reuse.
So we just covered the 4 physical levels of reuse, but what happens when the code itself is just way too specific to copy and paste? Well, that leads us to concept reuse. This is when you reuse an abstract idea, a pattern, or an algorithm instead of the actual physical code itself. You see, sometimes an existing system has a truly brilliant way of solving a problem, but the actual code is so tangled up in that specific application that you just can't extract it. So you don't reuse the component, you reuse the brilliant idea instead. Think back to Chapter 7 when we discussed design patterns. Design patterns are the ultimate example of concept reuse. You take the abstract pattern and you write fresh code that implements that pattern specifically in your environment.
Section 4. Benefits versus problems.
Now, as engineering professionals, we always have to evaluate the trade-offs of our decisions. And let me tell you right now, this is a major exam focus area, so I need your full attention here. Reusing code sounds like an absolute no-brainer, right? I mean, why build when you can borrow? Well, we really have to contrast the immediate benefits against the long-term hidden risks. On one hand, we've got accelerated development and lower costs, but on the other, we have creeping maintenance costs and some fascinating psychological barriers like the not invented here syndrome. Let's look at the exact specifics you need to memorize.
Okay, the crucial point for your test is that you must be able to list at least 3 benefits and 3 problems. Let's walk through this methodically. For the benefits, number 1, accelerated development. You bring the system to market much faster. Number 2, lower costs. Reusing software literally means writing fewer lines of code, which directly saves money. Number 3, increased dependability. This is a massive one. Reused software has already been tried and tested in real working systems. The bugs have already been found and fixed by someone else. And number 4, standards compliance, because reusing established components ensures your system actually meets industry standards. Now for the problems. Number 1, library maintenance cost. Simply populating and maintaining a library of reusable components for your team is actually quite expensive and time-consuming. Number 2, increased vendor maintenance costs. Think about it. If the vendor who created the reused component suddenly stops supporting it, or if you don't have the source code and it becomes completely incompatible with your system updates, your maintenance costs are going to skyrocket. And number 3, the not invented here syndrome.
I really want to drill down into that last point, because this brilliantly illustrates the uniquely human element of software engineering. The not invented here syndrome is a massive hurdle in our industry. Some developers, frankly, arrogantly, prefer to write their own bugs rather than use someone else's working code. They either lack trust in external components, or they simply find writing original code to be way more fun and challenging than just configuring existing software. As a manager, you have to recognize and overcome this psychological barrier within your team.
Section 5. The reuse landscape.
So recognizing the problems of reuse is what helps us choose the right tools, because knowing what the methods are is really only half the battle. Knowing when to use which method is what makes you a true software engineer. Over the past 20 years or so, so many techniques have been developed to support reuse. Just notice the vast array of options on this landscape diagram. From design patterns and application frameworks on one side, all the way to legacy system wrapping and ERP systems on the other. What this visually proves is that there is absolutely no single universal approach. The landscape is broad, and you must select the right tool for the specific job.
We have a table here breaking down those approaches. For your exams, I want you to recognize a few specific enterprise examples from this list. First, application frameworks. These are collections of abstract and concrete classes adapted specifically to create systems. Second, ERP systems, or enterprise resource planning. These are massive, large-scale systems encapsulating generic business rules that get configured for a specific organization. And third, legacy wrapping. This is super common. It's where you take an old legacy system and wrap it by defining a new set of modern interfaces so you can reuse the old code without having to rewrite the whole thing from scratch.
So, how exactly do you choose? Well, there are 4 key factors driving these reuse decisions. First up, the development schedule. If the client needs it done yesterday, you reuse complete systems, even if they aren't a perfectly elegant fit. Second, expected software lifetime. If the software needs to last for 20 years, you have to think deeply about long-term maintainability, not just a quick fix. Third, team skills. You must weigh your schedule against the background skills of your team. If they don't actually know how to use a specific, highly complex framework, the learning curve might totally negate any time you thought you saved. And fourth, system criticality. If you're building a system where a failure means absolute disaster, you need highly dependable, extensively tested reuse components to minimize your risk. So to recap this section, the reuse landscape is vast, and you have to weigh your schedule, software lifetime, team skills, and system criticality to choose the exact right approach.
And finally, Section 6, Course Summary and Exam Focus.
We have covered a fantastic amount of ground today. Let's bring your focus right back to the core takeaways required to pass this module. Here is your slow-paced, comprehensive recap of exactly what is highly likely to appear in your assessments. First, you absolutely must be able to define the 4 levels of reuse. System reuse, which is buying an entire system. Application reuse, adapting a product line. Component reuse, plugging in a subsystem. And object or function reuse, which is using standard libraries. Second, be able to list 3 benefits of reuse from our options: accelerated development, lower costs, increased dependability, and standards compliance. Third, list 3 problems of reuse: the high cost of maintaining a component library, increased vendor maintenance costs, and that fascinating not invented here developer syndrome. If you can master these lists, I promise you will do exceptionally well.
As we wrap up this session, I want to leave you with this final, somewhat provocative thought. Deciding whether to build or buy software is often a managerial decision, not just a technical one. As you grow in your careers, moving from junior coders up to senior engineers and architects, you're going to realize that writing the code is often actually the easy part. The real challenge is making the strategic business decisions to minimize risk and deliver real value. This perfectly sets the stage for our next topic in the Advanced Software Engineering syllabus, where we'll be exploring component-based software engineering in much greater depth. Thank you so much for your focus today. Keep studying hard, and I will see you all in the next lecture.